Hi, this video will help you review information about what we can learn from the period and the group that an element falls within on the periodic table. We'll also learn some characteristics of the different groups. We'll be very basic here. I'm just going to give you the information you need to do well on the semester final. So the periodic table is divided into periods. Those are the rows on the periodic table. So period 1 consists just of hydrogen and helium. Those are the two guys that are on the top stripe of the periodic table. They have one valence shell. That's it. Remember that that shell can only take 2 electrons. So hydrogen has 1 electron, helium has 2 electrons. That fills up that tiny first shell, and they're done. Period 2 on the periodic table, period 2, has 2 electron shells. That's composed of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3, period 3, has 3 shells. And period 4, for the purposes of the elements we discussed in class, has 4 electron shells. So remember that if you're asked a question on the test about how many electron shells an element has, say I ask you how many electron shells aluminum has, you could draw out a diagram of the whole element, or you could just find it on the periodic table and go, oh, well, it's in period 3, it must have 3 electron shells. So those are the periods on the periodic table. Another way they are grouped is in groups. So this is group 1 on the periodic table. It is called, here I'll circle the number 1. Group 1 is called the alkali metals. ALKALI METALS. This is the group 1 elements. Hydrogen, lithium, helium, hydrogen, lithium, sodium, potassium, and so on. The group 2 elements are also called the alkaline earth metals. There will not be a specific question about that on the test, so I'm not going to write it here. Then we have the transition metals, are the top part of this transition metals. The only thing I'm going to ask you about on the test regarding the transition metals is just what they are and where they are. We didn't talk a lot in class about their characteristics. I just let you know that's what these are. They're here. You'll be learning more about them in chemistry classes as you get older. Then we have this group. Here's the boron group, the carbon group, the nitrogen group, the oxygen group. In different books, you'll see these labeled with different numbers, and so we didn't use numbers at all in 9th grade class to describe these 4 groups of elements. We just described them using the top element in the group, boron, carbon, nitrogen, and oxygen. We also didn't talk a lot about the specific characteristics of these elements. They fall within the metalloids and semi-metals, and so their characteristics aren't super consistent as you go down the group. So we just kept it really simple in class this year and didn't talk a lot about specific characteristics common to each of these groups. Now, we did talk some about the halogens. That's the name of this group, HALOGENS, and you'll need to know the name of this group on the final exam. And you'll also need to know that they bond really readily with these guys over here. We talked a lot about things like lithium fluoride, right, and sodium chloride. So the halogens and the alkali metals really like to bond with each other, and that's something you should know. The other group that you're going to need to know about are these guys, the noble gases, NOBLEGASES. So those are the groups on the periodic table that you're going to need to know the names of on the test. Now let's go on and talk a little bit about some characteristics of these groups. The alkali metals, we watched some videos that were kind of cool that described these elements becoming progressively more reactive as you went down until we got to rubidium and cesium that were really explosive. I think we had a video of somebody dropping some cesium in water and breaking a glass. So that was pretty cool. So the alkali metals are, of course, they're metals, right? They're soft, they're shiny, They're silvery, and they're reactive, some of them very reactive. So those are some things that you need to know about the alkali metals. The alkaline earth metals, group 2, like 1, but not so much. The halogens, again, just you need to know that they react with these guys over here. The noble gases, you need to know that they are inert. You need to know what the word inert means. It means unreactive. And you need to understand why that's the case. Let's go back as we discuss that and talk about how many valence electrons are in each group of atoms. Alkali metals, 1 valence electron in each of these guys. Hydrogen has 1 valence electron, lithium has 1 valence electron, sodium has 1 valence electron. These guys, 2 valence electrons. Boron group, 3 valence electrons. Carbon, 4. I bet you could fill this out for yourself, even if you hadn't been in class. 5, 6, halogens have 7 valence electrons. The noble gases have full outer shells. The reason that I'm not writing 8 here is that helium has 2 valence electrons, right? Because helium only has 2 total electrons. It only has that tiny inner shell, and it's maxed out at 2. 2 is all it can hold. So it has a full outer shell even with 2. Neon, argon, and on down, they have 8. So don't think in terms of these all have 8 valence electrons. Just think they have full outer shells. So why are they inert? Why are they unreactive? Well, it's because those valence electrons are what indicate how reactive something is and what it wants to react with. Let's go ahead and talk about the block on your study guide that asks you to define a valence electron and the octet rule. Let's just make some notes right here on the periodic table. A valence electron is an outer shell electron. Outer shell electron. And remember that the reason it's important to know how many electrons are in the outer shell of an atom is that those are the ones it uses to interact with everything around it. So if something has 1 or 2 valence electrons, those are the ones it's going to use to react with other things. If something has a full outer shell, if it has 8 valence electrons, then it's already satisfied the octet rule. So let's define the octet rule. The octet rule says that atoms are most stable when they have a full outer shell. Atoms are most stable with full outer shell. So that means that since they already have a full outer shell, they don't want to react with anybody else. They don't care if they come near an atom that wants to get rid of some valence electrons. They don't want them. So these guys are inert. They're very unreactive. They're already stable because they have full outer electron shells. So this little video has reviewed the boxes on your study guide that talk about the period on the periodic table, the groups on the periodic table. We've defined valence electron, we've defined the octet rule, and we've talked about some characteristics of different groups of electrons. So I'm going to close this video now. Our next video is going to talk about ions and about ionic bonding.